Section 6.2, example 8, multiplying the power series. So multiply the power series of 1 over 1 minus x for absolute value of x being less than 1 with the power series representation of 1 over 1 minus x squared for absolute value of x being less than 1 to construct the power series for f of x is equal to 1 over 1 minus x times 1 minus x squared on the interval from -1 to 1. All right, let's see if we can do this. So looking at all of these, initially what we're doing is multiplying these two together. So multiplying that with that. So let's see what exactly that looks like. So starting off with that, we have like our initial value. So 1 plus x squared plus x cubed. Let's do 5 terms, x to the power 4. Continuously multiplying that with this other one here. So it's the exact same thing, only instead of each individual one, we're squaring those. So 1 plus x squared plus x to the power 4 plus x to the power 6. Continuously multiplying those together. So now let's multiply this, well, this right here with each and individual one of these here. So multiplying everything to each of those. So actually, why don't I do color coding? Let's make this pink. So now multiplying 1, so this one right here, times all of this. So copy and paste. So we're multiplying those together. Plus now we have x times that same thing. And that was 1 x squared. So now we're going to do plus x squared times all of that. Doesn't look like we have much room here, but let's see if we see a pattern. So now looking at each individual one, we could start off with 1. So how many 1s do we see? When we multiply this 1 through, we just get 1, and multiplying x through to all of these, we no longer have any 1s left. So now let's see how many x's we have. So here we have no x's. Over here we have 1x. So we have x. Over here we have no x's because the smallest one here is going to be x squared. Speaking of x squared, let's count how many we have. So we have 1. When we multiply this through, we have x cubed, but we don't have x squared. And multiplying this through, we have 1x. So plus, I'm sorry, 2 of them. 1 plus 1, x squared. And now let's look at x cubed. So here we don't have any x cubes. X times x squared, that's going to be our first x cubed. So far we have 1 x squared. When we multiply that in, that's going to be x squared, x to the power 4. But now looking at the next one, this is going to be plus x cubed, and then we have 1 plus x squared. So that's going to be 2. The following one is going to be a little bit too big, so we're not going to have that many. So here we have 1 plus 1 x cubed. And let's see if we could build another pattern. X to the power 4. We have 1 here, not here. 2 here. and then also plus x to the power 4 times 1. So we end up having 1 plus 1 plus 1. That's 3x to the power 4. And now that I notice that pattern, we could start building our series here. So we have 1 plus x plus 2 x squared plus 2x cubed plus 3x4 plus 3x5 infinitely. So what I think it is, I think we have n times 1 plus x or we could say, what is that going to be? N times x to the power of n minus 1 plus x to the power n. And there we go. Although I don't think we could actually state it like that. I don't think there's an actual function or infinite series that we could claim for this relation here. For this relation. But all they wanted was a power series. All they wanted was this part right here, which is what we have. And still, interval of convergence is still going to be from -1 to 1, just because it's an interval of convergence of both of them. So interval of convergence, -1 up to 1. And there we go. If you have any questions, please feel free to ask. Otherwise, bye.